My name is Thomas Schend. I'm system architect for Compugo Medical AG. And before we start the talk, I want to do some housekeeping. So feel free to ask questions at any time. Just raise your hand and I will answer them right away. We will have a Q&A at the end, but sometimes it's better to answer the questions directly. So I have some questions beforehand. Who knows Synnefo? Just raise your hand. Synnefo. I know it's a Greek word. I also needed to get used to this, to the pronunciation. So, who knows Synnefo? Okay. Who knows Ganeti? Okay, a little bit better. Then I will discard the 2-hour questions. Let's start. So here's a brief agenda. Today I will introduce my company and me, just 2 slides. Then I will cover what we need or what do we expect from infrastructure as a service. I will not call this cloud because I think it's a totally overloaded world today because everything is cloud. I will call this infrastructure as a service. Then I will introduce Synnefo and describe how it solves some problems uniquely. I will talk about the components in detail because it's one piece of software, but it has some different components. I will cover Ganeti in a separate part of the talk because it is the foundation for everything and does all the hard work. Then I will try to do a demo. I know they tend to fail, but I hope the Wi-Fi is working and I can show something. And then we do Q&A. Okay, I work for Compugo Medical AG, as I said. As a system architect, we are a software company. We write software for the medical sector. We write software for physicians, for laboratories, for pharmacies. We are in 35 countries worldwide, 385,000 customers. And maybe when you go into a physician in Germany, he uses our software. We have offices in 19 countries. The rest are just figures for the board. But important is we have data center operations in 6 countries. Here's a quick bio of myself. I'm responsible for infrastructure design. I came from an enterprise background, so focusing on, and as you can see from my certifications on industry standard stuff, I put the LPIC 2 at the front because I love open source software, and I do it since I think I installed my first SUSE Linux. It was on floppy disks. I don't have a Twitter presence or blog or Facebook profile. You can find me on Xing or on LinkedIn, or can just write a mail to my personal email address. Okay. What do we need from infrastructure as a service? So first and foremost, it needs to be reliable because the customer or the user expects it to behave as a normal server. And nowadays, we have seen that hardware failures have dramatically decreased. In former times, they failed very often, and RAID controllers and so on. But today, when you buy a server, it's barely that it fails. So you want your software stack be at least as reliable or more reliable to do some replication as a physical server. It must be scalable. So in 2 terms. First, from our perspective as the infrastructure provider, you need to be able to linear add new hardware and the system scales. Also, this is important for the customer itself because he says, okay, I want a virtual machine. Then I need, let's say, 8 gig of RAM, but the load increases. I cannot scale out. I cannot scale out right away because the architecture doesn't support it. Because, as I said, I come from an enterprise background. they have very often monolithic workloads, which cannot be scaled. When you have your Twitter or Netflix or something, you can just provision new machines, the load balancer does the rest, and it scales it, because the infrastructure is made for this. But enterprise workloads don't. They can scale up, but not scale out. So you need to support both. Easy to manage. I think reliability and easy to manage are two things which go close with each other. Because if something is hard to manage, it's very error prone. That we have seen if you don't deploy automation or something, then humans make errors, and we have seen when I look at our statistics that 80% of errors are human errors. And also, I talked about enterprise workloads, long-lived workloads. Not all virtual machines are EC2 instances, for example, because when you go to Amazon, they provide you an image, you boot the image, and you can get your data from an EBS volume. And if it dies, they say just restart it. For example, Netflix, they have a program called Chaos Monkey, which just switches off machines in their production infrastructure to prove or to show that it's really resilient at any layer. But I think that most companies are not able to do this. OpenStack, for example, have now the ability to boot off volumes. So they also saw that it's not enough to just spin up instances on local disk, and when they die, just restart them. For this, I have a quote from Vangelis Kouokis. It's the technical lead of Synnefo. VMs are not cattle, they are pets. That means when you have run a small mail server in this environment, and you say, okay, this is a mail server, it holds mailboxes. I want it to be persistent, and in case of any error, I want to fail it over and bring it back in, let's say, 5 minutes, or it comes back automatically. So I think this is something which describes our goal very good. Let's talk about Synnefo. Synnefo itself is open source. It's a Greek word. Don't count me what it really what it means. But it's open source. It's production quality infrastructure service. I think that is a very important piece here. This is run in production with, I think, about 8,600 VMs today from the core team which developed them. So they develop it and run it and open sourced it. And they can also share their operational experience. It's made for persistent VMs. As I said before, we want the machines to be persistent. And if it dies, we can fail it over. Commodity hardware. I think when you talk about scalability, you want to keep it as cheap as possible and also have it can replace servers as you like. So no SAN. For us also, if you run the SAN, it's always a bottleneck. So when you're in an enterprise environment, you see, okay, this is SAN, it becomes a bottleneck. You put more servers in front, which serve virtual machines, and the SAN becomes a bottleneck. Today there are scale-out SANs and all sort of stuff, and distributed systems like Ceph and so on, but that's more complex. Because when you see the Ceph cluster failing, it's not funny. Large-scale installation. It was targeted for large-scale installation from the first design phase. Also, a simple UI. I think that is also important, because when you look at the Horizon dashboard, a developer can use it, but is it simple enough? I don't think so. Or when you look at the EC2, the Amazon Web UI, it's not made for the end user. It's made for core developers or the internal teams at Amazon which develops their software, but not for an end user. And it also, that brought us also to Synnefo, is it uses Ganeti as a cluster manager. Because from our perspective, cluster management is really serious business. And you need to make sure that the cluster manager is the most reliable part of the entry infrastructure. So history of Synnefo. It was designed in 2010. Production since July 2011. That was the alpha phase. As I said, GRNet developed it as a core developer. They are running the service called Okeanos. That's the Greek word for ocean. It's a public cloud service currently running. I looked at it a few minutes ago, 8,700 VMs in a single infrastructure. They spawned about, I think, 300,000 VMs because it's also they're counting because there's some, GRNet is for the Greek Research and Technology Network. That's an academic organization. And there's some experiment that run, so machines get started, experiments run, and then they get discarded. So 300,000 VMs have been spawned on the infrastructure. So, as I said at the beginning, reliability is key. Here is the different layers of 3 infrastructure products. First, one commercial one. This is VMware. I think everybody knows it. Then we have OpenStack, and then Synnefo. Let's start from the bottom. ESXi, or VM kernel, that is really which runs the single virtual machines on a host. KVM for OpenStack, but you can replace it with Xen or Xen. I think Hyper-V is also supporting OpenStack, but Synnefo only supports what Ganeti supports. This is Xen, KVM, and LXC. Then on top, you need to manage the nodes. This is done with an agent in VMware. It's the vSphere agent. Then we have libvirt, which manages which provides an API for the node which OpenStack can talk to. And here we have a difference. Ganeti manages the cluster and the node as an entity. So you talk to a cluster, and Ganeti takes care of the rest. And here you see that OpenStack spans the cloud and the cluster layer. And the cloud layer is something really which is the broader management of different clusters. The API, and on top, I can think we will discuss it for a little second, and the UI. So when you update OpenStack, you need to update the anti-stack to get it working again. So they are working on this. They have I think it's OOO project, but they are aware of the problem. In Synnefo, it's a little bit different. So we have the Ganeti side, and we have the Synnefo side. They talk to another with an API. So that means I can update one Ganeti cluster at a time and still let Synnefo run as it is. If Synnefo is down for any reason, all machines, everything keeps running and is manageable. On the commercial side here, yeah, we have vSender, sucks, and yeah, it's painfully slow when you have lots of machines in there. Greetings to VMware. So, and then we have vCloud on top, which manages one or more vSenders. They have their own API. Synnefo takes OpenStack as an API endpoint, so you can use any tool like JClouds or whatever. Everything what speaks OpenStack can talk to Synnefo exactly the same way. Because we have, I think they have accepted, or they've seen that the ecosystem of OpenStack is very broad, and there are many companies which produce software for this. vCloud, okay, VMware is a big player. They have their own API, which is totally weird. On top, I think you cannot call it client because vCloud also provides a web UI. Then we have Horizon Dashboard and Synnefo again, which provides also a dashboard. Interesting is that the dashboard provided by Synnefo is just an application, a web application, which talks OpenStack to the backend. So theoretically, it could talk to an OpenStack cluster, and Horizon could talk to Synnefo, but I think that never has been tried. Okay, here is a bird's eye view on the infrastructure. Here you see the different layers. First, on top, there's the Synnefo layer with Cyclades or Cyclades. I don't know. The Greek naming is Cyclades, I was told. And then we have Pythos on the right. So Cyclades is really the layer which just presents the capabilities of the different Ganeti clusters in the backend. They are talked with an HTTP API, and they are different clusters. So if you talk to, if you go on the UI, it picks one of the clusters on its load and just provisions a new virtual machine. And on the left side, you see that the admin can just interact directly with the Gannett clusters. He doesn't need to go to the top layer. There is an ability to have user management and quota and so on, but in general, day-to-day work is done directly on the clusters, totally independent from the cloud layer. On the right side, you have Pthos. This is an object storage service. It has the ability for different backends for storing files. It supports Rados, it supports NFS and Gluster, but I will go in detail in a few minutes. So, Synnefo. Built with Gannett as a backend, that is most importantly. Now the naming. We have something which was not in the slide before, which is called Astacos. That's the pendant to Keystone. It's an identity accounting service, and every server you need to authenticate there, and then you get access to the different resources. The Cyclades, which has lots of stuff in it, but it's only the abstraction of the Gannett resource itself. So compute, network, images, volume service sounds like, okay, you put Nova and you have Nova on steroids or something, but it is more like an abstraction because Gannett does the work. Then Pthos, file object storage service, it's like Swift, but with an web UI. Their SNF, that is all the short naming for all Synnefo components. They are named SNF, so you can distinguish them from each other. SNF Manage is a command line tool where you can interact on the command line with the cloud layer. So seeing what servers, networks are provisioned, and so on. It has bash completion, so it's pretty good to work with. There's also a basic help desk tool integrated, so that means user comes in, sends something to a help desk with his email address. You can just put in the email address in the help desk tool and see what these machines are doing, how they are behaving, and so on. They have a continuous integration effort. It's called SNF burn-in. But more important for operations is SNF burn-in run. That is something really you can just run it and see how the performance of the infrastructure is. It just provisions a virtual machine, provisions network, and so on. And you can see from the performance matrix you get back from the script how your platform is behaving, and you really see, okay, it's working. Everything end-to-end is working. Kamaki, which is also a program. It's a command line client. It speaks OpenStack, and it's written in Python and can be deployed on Windows, Linux, and it's interactive, or you can use it, like any other command line client. Code is on GitHub currently. They moved it over there. First they had their own repository, now they moved it to GitHub. Okay, let's talk a little bit in detail about the components of Synnefo. Here is again the architecture. It's a little bit, it's just stretched what you've seen for a few minutes before. At the top, at the bottom, the different processes of the different clusters, KVM processes. Then we have the Gannett nodes, which have the Gannett node daemon, which is something which runs on every Gannett node and talks to a Gannett master daemon. That is also something which is unique to this system. You just talk to one master daemon, which is replicated over the first 20 nodes. So that means if this one dies, the node with the master daemon dies, your endpoint to manage the system, you just fail it over to another node and you're back operational. On top of them, there is the Cyclades system, which talks to the Gannett clusters. They both talk to Astacos. And on the right, there's Pthos, where you see the NFS backend and also the Rados backend. Here are the different OpenStack APIs. What you've seen on the right, they have some extensions to the Swift protocol because they support hashing and deduplication before you upload. So not in the backend, so they deduplicate on the client, which is pretty efficient. Okay, Astacos, as I said, and it is the identity service for the whole product. It provides also a dashboard. That is something, a dashboard is not comparable with Horizon. It's like really for your quota, for your authentication methods, because you can have multiple authentication methods against the system. They have implemented Twitter, Google, OAuth2, I think. Then they have LinkedIn. But for an enterprise workload, LDAP and Active Directory are more important. But you can have linked 2 of these authentication methods to one user. And also, for sure, internal. So you can have users directly on Synnefo and then have them right away. Also, what is not on this slide is you can have this moderated. So someone logs in. He can check if it's in the right LDAP group. And then he gets automatically access and resources. Or it needs to be approved by an administrator. Also here, project management. That means you can have projects, like you have a new infrastructure project or a new development effort. That's more our use case. You have a development effort and they need resources, and you don't want to spin up machines one after another for them. They need to do this on their own. Okay, features Cyclades. It does network management. So this is something, it's a thin layer between the network management doing in Cyclades and at the back end. So I need to explain this a little bit more in detail. That means, for example, I can assign a network. That means I have a class C network. I can say, okay, this is our private network we use here. Then we have the ability to start instances and the back end with DHCP, but it's not actually DHCP because Cyclades knows the MAC address, and on the tapped device, they have started an NF DHCP daemon, which just hands out to this instance one IP address. So it's static in a way, because it's only for this machine accessible, and we have it in the configuration. So that is something you can see what IP address is configured to this host in the Cyclades layer. They have different modes for isolated networks. First, layer 3 routed. That's like if you have a standard ISP, you do it the same way. You have your host. Then everything what goes out goes to a routing table. The routing table looks okay. This is one from this network. I send it out to my core switch, which does layer 3 routing. So you are not on this. You can be on the same broadcast domain, but you cannot reach your neighbors with layer 2. Also, isolation for private systems is layer 2 VLANs. So this is, I think, not scalable. You have nodes, you provision VLANs, and in this case, bridges for your different VLANs, let's say 100 VLANs per server, and then they are handed out to the different machines. This was not very scalable. Then there's something which is, I compare a little bit to VXLAN. That's the VMware side, or I think it's standardized from IEEE, I'm not sure. Layer 2 isolated MAC address means I create a private network. That means I have the first digits, the first 6 digits are the prefix of the network. Then I have 2 machines which want to talk to each other. The system applies a MAC filter for outgoing MAC addresses on the tap devices of the machines belonging to this network. So in general, if you are on the VLAN, you can see all traffic, yes, but machines are isolated on the host directly, so they cannot get out or in, which are just I think it's EB tables filters directly on the host. Archipelago storage abstraction. This is something they introduced, I think a few months ago. It's Archipelago. It's a name of some small islands in Greece. So it is something, they call it software-defined storage, but I think it's more a buzzword. It's something, it abstracts the storage backend from the end user. In the end user, in this case, is Cyclades. They have a gateway where they can talk to. And at the backend, it supports Ceph, NFS, cluster. Cluster is a little bit rough on the edges, but Ceph and NFS works pretty good. So let's start with Ceph. Ceph means just you have Archipelago, you upload an image with the Glance API, to Archipelago. It places the blocks on Ceph. Now, when I want to spawn a machine, Archipelago has also a block driver. That means the instant it makes a snapshot and starts the instance. So it's not like in OpenStack where you need to copy it over completely and then start the machine. So it's on the same backend. I think with tiering, which is coming in Firefly, this will be pretty good. Else you need fast clusters with not so slow disks, because block and in virtual machine storage, file and instant virtual machine storage are a bit of a difference. So it enables very fast cloning and snapshots. Snapshots also work on NFS because Archipelago does this. The PFOS layer. Object Store Service speaks Swift with some extensions because it enables efficient syncing. That means efficient syncing, I mean, with it splits everything up in 4 megabyte files, and then in 4 megabyte blocks, 4 megabyte blobs, and every blob is hashed. Before you upload, the client hashes the file, sends over the request, I want to upload block with this hash. Then the backend checks, okay, I have this blob already. It just makes a reference, and you don't need to upload. So you can sync if someone has done the job for you and uploaded a Windows 2008 or 2 image, for example, and you are on your 3G connection or flappy Wi-Fi, then you can upload it in seconds because it sees only the differences. And we have seen very good reduction in this. With the same mechanism, deduplication is achieved. Yeah, for sure. It has a web UI where you can access files. It's written in GWT, the Google Web Toolkit. So you can click with the right mouse button and so on. Clients are there for syncing Windows, Mac OS X, and iOS currently, also for iPad. And it's like Dropbox. I think I can compare it like Dropbox. It has very good functionality. It's not on par with, let's say, our own cloud, but that's also not the main goal. And there's sharing public and private, which I'll show you in the demo. Okay, communication. As I said, Synnefo and Ganeti talk to each other with an API. But the update file is totally asynchronous. That means we have the Cyclades web application, which talks OpenStack to an API server on the left. On the left. The API server is something which can be run in multiple instances, just for redundancy or scale out. Then it talks with the RAPI, which is an HTTP API with JSON, to the Ganeti master. The Ganeti master enqueues the job. And you don't want to wait till this is done. So the update file is asynchronous. Ganeti master executes it. If it's a job, when the job is done, the Ganeti SNF GNT event daemon watches the Ganeti queue, which is just a directory with iNotify. Then he gets an info, okay, job is done. He puts it in a RabbitMQ with the AQMP protocol and puts it in a RabbitMQ server. This can be redundant, as you see. You can easily FHA with RabbitMQ. ZeroMQ, I think you can also run ZeroMQ, but the reference architecture is RabbitMQ. Also, we have other things which is done on the nodes of Ganeti, which you want before the job is completed. So you want to see process while the job is completing. That means, for example, you have copy over an image, because if you don't lose Archipelago, you need to have copy over an image from your Glance store, and then you want to see process in the web UI. So this is a SNF process monitor. Also goes to the queue. Then we have a logic server. It's called the dispatcher. It looks at his transports of the RabbitMQ server. Looks, oh, my job is done. It has a job ID, which was before submitted by the Cyclades application and put in the database. He can also access and sees, okay, these jobs I need to monitor. And then when the job is done, it updates the database, and the Cyclades web app gets back the status. So that is totally asynchronous and scales very well in this case. Okay, architecture 2 for Synnefo. I've not mentioned it. It's written in Python and Django, so pretty on par with, I think, OpenStack, but they're accepting more stuff nowadays. It uses Apache Unicorn, but you can use Unicorn, you should keep it as an application server, but you can place Nginx, whatever, mod proxy. You can Apache with mod proxy, so nothing fancy. It uses a Postgres database, but it uses Django implementation where you can have SQLite or whatever for testing. But in general, Postgres is a reference of the architecture. It's easily been made highly available, so why not keep it? The event daemons I talked before, which run on the Ganeti master, the event daemon, and the process mon on the Ganeti nodes. RabbitMQ for the queuing service. The dispatcher, which fetches the updates. There's something I've not mentioned yet. It's this SNF VNC out proxy, because we want to provide an out-of-band call for users. But we don't want to have any dependencies or connections directly to the backend. So in this case, it's for VNC. It's nothing special. So if a user requests access to the out-of-band console, the VNC out proxy generates a one-time password, which I think it's for 30 seconds. And the one-time password is passed to the Synnefo web client, and then it accesses the backend. So works pretty well so far. Synnefo itself uses a Java console for now, because 2010, no VNC was not that good. Nowadays, they are going to switch. Everything is built on Wheezy. They started with Squeezy, then they migrated to Wheezy. It can be fully virtualized, so you can have a Ganeti cluster in the cloud and have to manage all the systems running there in the single box, or you have different instances for the different components. Speaks OpenStack, but does not share any code. I think that's also important. They don't depend on OpenStack. They just mimic the API, and they don't depend on what OpenStack is doing. Also, when deploying images, because in a cloud, you want users to be able to upload images which are untrusted. And that is something because Ganeti came from just internal deployments which are not made for public deployments. This is a secure image deployment tool of untrusted images. These are completely isolated from the Ganeti nodes, because Ganeti is pretty old, and they have done some nasty things. So before they start an instance, by default, they mount it in the Ganeti node itself, and then they do injecting files. And it could be able that the evil guy puts something in there, it gets, and you take over the node. It supports currently Linux, Windows, and BSD for deployment. And it does customization tasks. That means it assigns a host name, deletes SSH keys, if you have not done it before. Then it changes the password to a random one. Resizes the file system, also on the BSD systems now. It runs an unattended install on Windows. You can provide an unattended XML file with how you want to customize your systems, and also can inject files with a personality. Here's the process of how the deployment of SNF image really works. So first, you need to create a small helper image. It's called a helper image. It's just a small VZ installation with some tools for partitioning and so on, with NFS 3G version, parted, and so on. This is created once. Then, when you create the first image, it just copies over with DD, or it just syn clones the virtual machine image. Then it puts in a floppy, and the virtual machine helper boots it up. It reads the configuration from the floppy disks, does the customization, and then it shuts down and hands over the image to the actual system. So completely isolated, no matter what's happened there, it's not affects the host in any way. Okay, Ganeti. So also we came to Synnefo because we were used to Ganeti and say, okay, this is just working, and we want to keep it. So it's very major production ready. So you deploy it and it just works. Open sourced since August 30, 2007 by Google. It's used by Google in many locations, but we'll explain this in a minute. It uses only major open source tools. It uses DRDB, LVM for the volume management, Python and Haskell as programming languages. But more of Python and Haskell, so no fear. It supports different hypervisors. You can act with different hypervisors with the same commands. Xen, KVM, LXC as a beater. And it's easily to port new hypervisors with commands, because in general, you don't need to support all command sets. You can just say, OK, I want to start it, I want to provision it, and stop it. That's it. It has a very low overhead for the cluster management. OK, usage at Google. I think they run it in all offices. They call it Office in a Box, 3 to 4 nodes in all offices running low latency services, like proxy and DNS servers, and something you don't want to have in the data center, which are low latency, and maybe some VMs to play around for the developers. They have large-scale installations for their virtual desktop, so every user has a virtual desktop. They mostly use Xen, because as I started, the performance of KVM for the I/O was pretty bad. I think that also a thought everywhere in this presentation, so I will say it here, it's not used for user-facing services, mail, Google Mail, search, whatever, and also not the Google Compute Service. They don't use Ganeti for this. Features, it scales from 1 to 200 nodes. You can really start very small. You can have 1 node, provision machines there, you have no replication, but you can have it running, test how it behaves, and if you then say, OK, at the second node, you can just say, add replication to this with just 1 single command. It supports live migration without shared storage with the help of DRDB. Node roles, there are different node roles for the different systems. There's a master, which is your entry point for the cluster. Master candidates, which gets replicated this cluster state automatically. And regular nodes, which just run virtual machines. You can have node groups. So, for example, like an entity, like a rack. You have an entity rack of servers, top of rack switch, and you don't want your replication to go to the next switch because the performance is way better in this rack if you keep it on the backplane of the switch and not go to the next switch. So you can have a node group. This can be tied how you want it. OVF tool, import tool. Open virtualization format, so Xen, Citrix, VMware, they support it, and then you can convert it to a virtual machine from Ganeti. There's an included backup tool. I mentioned it here, but we don't personally use it that much. It's rough on the edges a little bit. A job queue, Ganeti Master Daemon provides a job queue, so you can submit jobs, and they will execute it, one after another. So all commands are consistent. They start with G and T. Features 2, they have an OS interface, provision new instances, just a set of small scripts which are there to provision new servers with like create, destroy, etc. So you can write your own interface for them and then say, OK, I want to deploy a new instance. Just run the create scripts with the environment variable passed by Ganeti. As an F image, as I said before, the secure image deployment tool for untrusted images, and they are also Ganeti debootstrip for deployment, Ganeti an image deployment tool, which is just to have a raw image, and then make it a Ganeti instance, and OSDF. These are the different on the website. Something what I think makes it unique is the H tools. The H tools are written in Haskell, and they're for balancing, plan capacity, and do maintenance of the cluster. As a storage backend, for default, Ganeti supports files, so you can have just a raw image. You can take a normal raw MDK, put it in there, create an instance, say, OK, this is your disk, and it just runs. Then plain means an LVM volume, shared file when you have NFS or cluster. Ceph, it can use RDB volumes with the, I think it's a KMO driver. If you have the KMO driver, it uses the user space implementation. Then you have NFS and cluster. And here also clusters are a little bit of the rough edges. So if you don't want to use a shared file driver, you can directly use the cluster driver. There's an X-storage provider, which is something you can talk to an let's say an external storage system, which provides an API. So for example, its Archipelago has its own driver. Then we have an EVA from HP, an IBM Storewise. These are today implemented. So, but you have any other storage system, like you name it, EMC, whatever, which provides an API. You can put in the scripts, which is This is similar to the OS interface. You have just small sets of commands which get executed with environment variables, and these are then passed to the system, and it needs to get back information. So in general, if you want to implement something and say, okay, I have a storage system, I want to use it with storage, the tools are there. Advanced features, as I said, H-tool, we have hooks. So Ganeti is more like a backend system. It means every action can have a pre or post operation. So before you execute any command in Ganeti, provision instance, migrate an instance, you can run something, and when it's completed, you can run also a post. This is also done for, as I described earlier, how it integrates with Synnefo. So it gets back information when the job is done. Every object can have tags. Tags is just a free text field, or not one free text field, it's multiple free text fields. So for example, tags can be used for needs a reboot. This instance needs a reboot. You can put in there the maintenance window or a contact person or whatever, or what purpose is it? It's production, it's not production, and you can just query it right away and see this instance had this abilities. And this can interact with your configuration management database. The tags are for every object, so it means cluster, nodes, virtual machines, also networks and so on. Exclusion tags, so if you want to place a machine, you can have exclusion tags on the cluster. You have two DNS servers, and you don't want to end them up on one physical node. Or Elasticsearch nodes. What we do is, because we don't run a distributed file system in the backend, we only run DRDB. And when you have 8 disks or 16 disks in a machine, it's dog slow on the I/O side. So what we do is we just deploy Flash in the machines in front of the RAID set we have, and then we replicate it. So with DRDB. So with Flash, you locally read from your Flash device most of the time. The Flash cache works pretty well. Nowadays, DM cache, I think it's a merge of Bcache. We will give it a try in our test environment, but Flash cache, we get decent performance. So all reads are local Flash, and when you write, it just goes over the network to 2 Flash devices. It has an out-of-band management interface, so if your nodes have an ILO or IPMI, you can use it. The Ganeti Watcher makes sure that all the nodes have only the instance running which belong to them. So if you switch off a node, start up back again, it will start up the machines and see, okay, these machines belong to me, I start it up again. Advantages. No need for special hardware and SAN. When you start, just a bunch of servers, local disks, that's it you need. Here you go. But if you say, okay, we have a requirement for shared SAN, huge amount of storage, it's supported. The cluster is managed as an entity and not as a single server. It has very few dependencies. It requires no database at all. So as I said, the replication is done by Ganeti for the configuration and the cluster state. On the first 20 nodes in the cluster, you can make this more or less. That's on your side. Easy recovery of hardware failure. I will show this in a second. Then there's no single point of failure for the sorry. For the reliability of the VMs. That means I can install completely. When I do an update, we can uninstall Ganeti on the nodes, and all KVM processes keep running. DRDB replication keeps running. We lose the management in this case, yes, but all machines just keep running. And it is a very good documentation. That's also true for the Synnefo. So I think an open source project with bad documentation doesn't help anybody. Okay, some best practices. Deploy automation, Puppet, Chef, CF engine. When you do large scale, I think everybody knows the first 2, you need to have automation to keep your nodes first installed, everything in the same way, and second, to keep them consistent with your configuration. Monitoring, yeah, that's a no-brainer. Then Open vSwitch, LACP. So we run Open vSwitch because for the flash performance, we have 2 10 gig links per node, which run LACP. And Open vSwitch, because we have seen that with bonding VLANs and bridges, the performance after 4 gigabit gets a little bit slow. So with Open vSwitch, the current version we are running, we can saturate the 10 gig pretty easily. Auto repair, that's also something which Gennady provides. If a node fails, that you can make your instances again highly available. And it has packages for all major distributions. It's in VZ backports, the current version of Gennady. And also there are packages for Red Hat and Ubuntu. Management interfaces, we have in CLI, which generally speaks to the LuxI interface, which is sitting on a socket. All commands do this, and we have RAPI, which other programs talk to. There are different web UIs using the RAPI. There's a Gennady Web Manager, which is developed by Oracle Open Source Lab. There's a Gennady Manager, which is developed by GRNUT. This is something two different products, which are just simple web cluster managers. Gennady Manager is more like you have a self-service, you can request a machine and not be approved by an administrator. And Synnefo is really cloud. Users can provision machines without the interaction of the user, of the administrator. And Gennady Map Manager is more like, you compare it like a vCenter something. It's cluster manager, permissions, and so on. Some brief command reference. So all commands, Ginty interacts with the cluster. You can init, info, what is going on in my cluster, what are the parameters you can verify. Is my cluster happy? Just one command. It checks lots of stuff if everything is happy. Then you can use command to execute a command on all nodes or node group or set of nodes. Then you can copy file. You just say, okay, I have a cluster of 40 nodes. I need to copy a file. It has it is on the master, and it just copies a file over every node. But you need to take care that that really is working as expected. Ginty node add. You can add nodes. You can list the abilities of the nodes. Ginty node list shows what nodes we have in the cluster, what's the free memory, what's the free disk. Failover. If a node dies, we want to fail over the instances, and evacuate, we want to move back away the storage space from this node. This is only true if you don't use shared space. The instance, add information about the instance and replace disks. Replace disk means, I will show this in a brief second, how this is really working. Job queue, you can list what's going on in a job queue. You can manage the networks I said before, and also back it up, but I would not recommend it at all. Here are the tools for the allocation. Hail is called and figures out, okay, where to place the instances when we first create it. We have space, and where is a secondary free where we can fail over. So it makes really sure that you have a rack of servers, and it figures out the space where to put new instance with DRDB replication or with shared storage. HBIL is if you want to do the same with Hail, but for a running cluster, and really to make it really narrow to distribute the load on all nodes. HSpace is your tool to plan capacity. HAREP is for auto repair. I said before, you can have tags on instances. For example, you can say reinstall. That means this instance is broken. Just reinstall it. So it executes the OS scripts for an Apache web server. It gets reinstalled. It picks up the Puppet agent is already installed, and it fetches the configuration for Puppet and gets back to the cluster. So this is if you go this way. hinfo is just for placing in the current situation of the cluster for archive purposes. And hroller is when you want to do rolling reboots. It figures out what nodes can be rebooted at the same time. So a typical Gennady cluster looks like this. We have flash in there, then we have a local RAID set, and we start with one node. Then we init the cluster on this node. We install all the software, hypervisor, and cluster. Cluster in this case is just a DNS name we need to ping, because it has the master daemon gets one virtual IP address which can be shifted around, so we have one single point of entry. Then we want to add another node. Second node, -S is for the replication network. So you can separate it for live migration and the DRDB replication from your production network. And we want to add a third node. And then we can want to verify what the cluster is doing. So easy as that. And adding additional nodes is the same procedure. And creating an instance, we can say just we want a DRDB. We want -hail for just use a cluster allocator htools. And we want the OS instance with dbootstrap, so it's a Debian instance running with dbootstrap, and we call it VM. It takes the configuration. There's a default you can set for, let's say, 2 GB RAM, 20 GB disk, and so on, and 1 CPU, and it takes the default. And then it figures out where to place it. I just have done this random here because it will look at every step, where is space, where can I do the failover. So because it's a DRDB, it has a primary and a secondary. And then I've provisioned the machines just executing the command. I don't need to care if I have 3 nodes, 50 nodes, 100 nodes. So, but more important, I think, is more, if you have 100 nodes, you don't want a single point of failure. You don't want that if one node crashes, or let's do, in your Ceph cluster, 2 nodes are crashing, and you have a rotation n+1, sorry. And you don't want that all machines are dying. So with DRDB, you don't have this problem. So in this case here, the machine on the right machine on the first node 01 has replication to the local disk and replication to the node 2. So if the first node is failing, we may have to make sure that it's really dead. So operations can shut it down with, let's say, IPMI, or take a look, can we rescue it? What's happening with the node? Let's say that it's dead. And then we tell Gennady, okay, stop all interaction with this node. It is offline. It is dead. Okay, it takes away replication. If there is any, it just removes the DRDB replication and shuts down the device. Then we want to fail over the machines which were on this node because it's offline. Now we fail it over, and we just don't need to tell where we don't to place the machines because they can only go to the secondaries. Okay. So it's failed over, and the machine on the node 1 is started on the second server on the secondary disk. But now, if this server fails, we don't have redundancy again. So with a second command, which is called evacuate, which moves away all the replication to other nodes in the cluster, it establishes replication again. So 3 simple steps to recover from a node failure. So just a quote from the Gennady list, I think that brings it down pretty good. It's from Martin. Yeah, Gennady had any special name meaning before this project. Now it means kick-ass cluster management. Okay, demo. We're running out of time, I see. I wanted to show a little bit, but I will speed up here a little bit. I want to show syncing and so on. I skipped this. I think I will provision just a machine. Let's see if this is working. Yeah, it looks like this. Wi-Fi is working. So, okay, I'm already logged in. This is the dashboard itself. As I said, this is what Stackhouse provides. You have here the different services. On top, Cyclades, the object storage service, Pithos, the dashboard, and at the front you can place just your homepage or something. You have the profile, where you see what authentication methods are enabled. At the bottom, you see, as I said, Twitter and so on, you can enable them. You have API access, so you can download directly a configuration file for your Kamaki client here, so install it. Just download the configuration, it's that simple. If you have other clients like JClouds, you want the OpenStack API information, you can use it. So here, excuse me?
Nice password.
Okay, now you can get it and shut down my VMs. So here is the resource usage. As I said, it's tracked, and it shows you how much quota you have. We have storage space on the one side, system disk for spin-up machines, which are replicated, CPUs, RAM, virtual machines. You can also limit your users to virtual machines. You say, okay, they have decent amount of RAM, but you can only spin up 3 machines. Then private networks and the floating IP addresses. The project stuff, which I said before, you can have projects, let's say a new development effort assign them resources, and then they can send invitations to users or accept them. Let's spin up a machine. So now I'll get to the Cyclades web UI. As I said, this is a web UI which loads on my browser and talks OpenStack to the backend. So it runs entry in my browser. So we have here the tab to install machines. Here we have the network configuration. It provides currently IPv6 and IPv4, which are the public ones. Here you can request IP addresses. Here you can create SSH key pairs to be injected into your instances, or you can upload your public key, which gets also injected in the instance. So let's spawn a machine. Here you have a list of system-provided images, which is maybe from the administrators. And you see everything we talked about. Let's take a Debian desktop. Also my images, these are the images I uploaded to Pithos, then shared with me. The sharing functionality of Pithos, someone else shared it with me. Or again, public, so you can share it with anybody. But if you click one of these are the public images. And when you click, for example, where is one? Here? No. Where's a public image? I think this one? No. Isn't there a public image in here? This one looks like. Then it has a notice at the bottom. Make sure that you know what you're doing and what the source of the image is before you apply anything in production. So back to the Debian desktop. Next step, we can see how many CPUs I'm left. We have to take one CPU, memory size, let's say 1 gig, disk size 5, and then the user has the ability to select the storage backends here. You can say user X can use these storage backends, or the other user can only use this. We have standard, which is the DB replication I talked about, which we all mostly use. Then there's the Archipelago backend, which is for thin cloning. I will use this to demonstrate how fast it is. Or local, which is just an LVM. This is compared to an EC2 instance. Just on the local disk, no dies, it's gone. But I would not offer this to the clients or the users, because it makes it harder to do maintenance, because if you have it only locally, you need to convert it to DB, move it over, and so on. So everything without live migration sucks. So Archipelago. Now it gets automatically IPv6, but I also want IPv4. I get an IP address. It gets automatically from the network pool. It gets assigned. Then I can get it a name. Here I could inject my keys, but I don't have one. We can also get tags to this. This is just for further, that you can see, okay, this one is a proxy or whatever. This is also a free text field. Then we have a summary, and then we just start it up. Now it sends to the backend, and it just randomly gets the password. You see, easy to type. And now it works in the background already. You can click here and see what, come on, what steps are currently done by the process mount. So you see what customizations are done, no swap is added, and so on. So you see really what is doing. But also when you look at this here, you see what image is completing, and it has a name. It's already up and running. So we have 3 different views: the list view, and a more totally info view. Here's also, you get performance information. This is Collecti running on every Ganeti node, providing these instances, images. So if we keep it running, you get Collecti graphs from every machine for CPU and network in the GUI. So the user can see, oh, here's something really wrong. And then you have the standard stuff. You can reboot it, shut down. You even open the OOB console, resize, do a snapshot, or destroy it. I think we're a little bit out of time. Talking too much. Sorry for that. So just 2 slides, and then. So, at least I would recommend you just take a look at Synnefo, or maybe just Gannett, and then it tracks you maybe to Synnefo. I would recommend give it a try. It's not a waste of time. Okay, thank you very much.
Thank you, Thomas.